all you have to do is give us your 90 days and we'll help you in upskill and grow. So choose your favorite course, go to our website, start learning, and we are ready with your refunds. We have helped thousands of students and they have got more than 5 crore rupees of refund. So it's not only helping them in monetary terms, it's also helping them in being consistent and complete the course. So last year our completion rate was 20%, and with 390 challenge, we have seen it significantly going up. See, the idea of 390 was to make students motivated in the form of money, so that they complete the course and they get money. But our main aim was to make students consistent so that they become market ready.
All right, so hi everyone. Myself, Ayush Tripathi. Currently, I'm working as a mentor at Geeks for Geeks, and welcome you all to this post analysis discussion of last weekly contest 192. So, how was your contest? How many problems you were able to solve? Cool. So everything seems good to me, and we are good to start the discussion. So most of you have solved up to two problems only. Don't worry, we'll discuss the solution of all the four problems completely. And I personally categorize the entire contest from medium to little hard. The first three problems was doable. There is no prerequisite at all for the first three problems. And for the last problem, you need to know some advanced technique. So we'll discuss the solution for all the problems, and for the last problem, we'll discuss the prerequisite. And if you are not done with the prerequisite, then I would highly recommend everyone just go and cover the prerequisite and then come and listen to my explanation for the last problem. Solved three using DP, but some case not pass. What you can do, you can like post your DP solution in the comment box, and we'll elaborate your solution and will provide you the test cases for which it failed. Anyway, let's just start with the first problem, which was a fairly easy problem, and I guess it is a cakewalk for everyone. So, hope my screen is visible to you all. Let me change the template. Maybe this one. Yeah, this one. Yeah, seems good to me. So this was the first problem. Absolute difference array. So in this problem, you are given a string s of lowercase English letters, and your task is to find for each index I the absolute difference between the frequency of vowels and the frequency of constant in the substring from 0 to I. Cool. And we need to return an array of length n, where n is the length of a string s, and ith element is the absolute difference between the frequency of vowels and the frequency of constant in in the substring from 0 to I. So the problem statement is fairly straightforward. Now let's just directly jump on to the solution. So basically we have a string of length n. So the first character s of 0, then second character s of 1, then s of 2, let's say some character s of I, and up to s of n minus 1, the string of length n. And for every substring, so for every index I, which starts from 0, the value of I, and it goes till n minus 1, I need to know the frequency of vowels and the frequency of constants. So frequency of vowels in the substring from 0 to I. And we can build this thing in a progressive order. And this variable v that I will initialize before the loop and with the 0. And every time we'll increment it if the ith character is vowel. Otherwise, we'll increment the consonants, right? So another variable c, which I will initialize with 0, and it stores the frequency of consonants in a substring from 0 to I. And we can also build this in a progressive order. If the ith character is a vowel, then increment the value of v, otherwise increment the value of c. And answer of I is equals to the absolute difference. So absolute difference of v minus c. And this is the complete solution. And what will be the time complexity? The time complexity here is order of n. And extra space, we are using this answer array. So auxiliary extra space, which is also order of n. Now let me show you the implementation. And yes, this is the implementation in a C++. So this is the method that you need to complete, and with string s, then size of string s, my answer vector, then variable v and variable c, v for vowels, and the variable c I will use for a consonants. Then I iterate over all the indexes from 0 to n minus 1, and if the ith character is vowel, then increment the value of v, otherwise the value of c. And answer of I is the absolute difference of v and c. Cool. Then here is my function is vowel, which takes a character C as a parameter, and if the character is either A, C, if the character is one of the five vowels, then I will return true, otherwise I will return false. Cool. So this is the complete solution. Clear to everyone? Write a quick +1 if it is clear to you. The time complexity is linear, space complexity is also linear. Cool. So coming to the next problem of the contest, and this was a pretty interesting problem. Wooden flank. So how many of you were able to solve this problem? How many of you were able to solve this problem? All right. So if you were not able to manage this problem, no worries at all. Just listen to my explanation. So you are given an array ARR where each element represents the length of a wooden flank, and your task is to construct the longest possible fence using these flanks. And the fence can be made by placing two flanks at a distance of 1 unit. This information is not useful. But yes, we can combine the two flank, and you are allowed to combine at most two flank to form one flank. Basically, you can combine the two elements of the array. However, joining three or more flank is not allowed, as it would compromise the fence integrity. So we can combine the not more than two elements. Furthermore, the length of all the flank used, either single or combined, must be equal, right? And our task is to return the length of the longest possible fence that can be built optimally. So for example, let's say this is the array. So here what I can do, I can combine, I can take a one flank of length 1 and another flank of length 4, and we combine them together. Now the new length of the flank is 5. Now we have a two flank of length 5 each. Then I can combine one flank of length 2 with another flank of length 3. So now the new flank length is 5. So now we are able to form four flank of length 5 each by not violating any condition at any point of time. We are not combining more than two flank together. So in this case, the total length of the fence is 3. right? So the number of flanks of length 5 that we can form, and minus 1. So 4 minus 1 equals 3. This is your answer. So now let's discuss the solution. So let's just first store the unique length of flank and their frequency. Okay, someone saying your voice is not clear. Okay, too much lag in our streaming. Okay, just allow me 1 minute. All right, so like hopefully it is fixed now. So sharing the screen again, and let me just quickly summarize the problem statement. So basically in this problem, you are given an array ARR of length n. Here we are allowed to combine at most 2 flank to form one single flank, right? However, joining to more than 2 flank is not allowed. This is invalid, right? And we need to find the length of a longest possible fence using these flank, right? And the length of all the flank that we will use to form a fence must be equal. So for the first sample input, what I can do, I can form a flank of length 5. Now let's just find how many flank of length 5 we can have. So here we have one occurrence of 5 and another occurrence of 5. So I will use these two flank individually, right? And then I will take a flank of length 1 and another flank of length 4 and will combine both the flanks together to form a single flank of length 5. Now we'll take one flank of length 2, another flank of length 3 and will combine them together to form a flank of length 5. So in total, we can have a 4 flank of length 5. This 5 and this 5 individually, then these two flank which we have combined, and then these two. So the total length of the fence is 3. The number of flanks minus 1. So the number of flanks that we have is 4 and minus 1. This will be the length of the fence, which is maximum possible. So I hope the problem statement is clear to everyone. Now let's just listen to my explanation. Okay, someone saying why minus 1. So basically this is simple definition of the problem statement. You need to find the length of the fence, longest possible length of the fence. So if I combine two flanks, then it would be considered as a fence of length 1. So if I am having 4 flank, then this would be considered as a fence of length 3. So this is as per the problem statement. There is no rule given here. So wooden flank. So let's just first find the unique length flank and their frequency. So find flank length, or I can say unique flank length, and their frequency. So let's just store this information. Store this information in some 2D array. Let's call this array as V, and it is of size 2. So here V of I, comma 0. Yes, Kotsam, you are right. So V of I, comma 0 will store the length of ith unique flank. And V of I, comma 1 will store its frequency. Its frequency. Cool. Now, after getting this information, let's just find the contribution of each and every flank, each and every ith unique flank. So for that thing, and basically how we find this information, how we create an array V. So this is a fairly easy task. We'll use a map data structure, and for every element, increment the value corresponding to the key. Let me show you the implementation for this. For this array V. So this is my array V. And this is basically a 2D array V. So here I have, this is my frequency unordered map. For every element, increment its frequency, and then they simply create an array V. Because operating over the arrays are much simpler as compared to the map. So that's why here I copied every key value pair in this 2D vector. Cool. Basically, simply this information. And once you get this thing, then I will declare another map. Let's call this as a sum. And here what this variable sum will store. So sum, this map sum will store. So sum of key, that is let's call this as a sum of x. So the sum of x will store number of flank possible of length x after performing all the operations optimally, after combining some flanks, after using some flank individually. Sum of x, that is value corresponding to the key x, will store the number of flank possible of length x. And what will be my answer? My answer is equals to maximum value corresponding to any key and -1. We all know why it is -1, because this is the length of the fence. So this will be my answer. Now the thing is how we update this map sum. So for that thing, I will find the contribution of each and every ith unique flank. So for every unique flank, let's call this as V of I. Unique flank V of I will find the contribution. So find its contribution. So we all know V of I 0. It is the length of the ith unique flank, and V of I 1, it is a frequency of basically the number of flank of length V of I 0. So frequency. Now what are the possibilities we have for every flank? For every flank I have a possibility to use it single. So when I use the flank single, individual, so use single. So in that case, the sum of V of I 0, that is I got these many flank of length V of I 0, and how many flanks are there? It is V of I 1, this frequency. So I have I have these many flank of this much length. So basically the number of flank possible of length V of I0 will increase by V of I1. This is a super simple logic. Now the second possibility. The second possibility, when I use two flank, now try to pay more attention. The second case, when I will use two flank of length V of I0 together to form one flank of a bigger length. So basically double length, I can say. So double length, and that is joining two flanks of length V of I0. Cool. So I will increment the value corresponding to the key V of I0 plus V of I0. That is 2 into V of I0. So sum this is my key, basically the length of the flank, resulting length of the flank, 2 into V of I0, and will increment this thing by V of I1, the frequency, divided by 2. So let's say, let me give you an example. So let's say you have a 5 flank. Let's say you have a 5 flank of length 2. So length 2, 2, 2, and 2. So here in this case, V of I 0, it is equals to 2, the length of the flank, and V of I1, it is equals to 5, the frequency. So here, how many flanks we can form? How many flanks we can form of length 4? That is, when I double this flank, we'll combine two flank of length 2 and 2 each. So this is a 2 plus 2 and plus equals to 5 divided by 2. I will take these two flank and make one single flank, and I will take these two flank and make one single flank, and I cannot combine this with any other flank, right? So that's why sum of 4, that is value corresponding to the key 4, increment by 2, 5 divided by 2, and take the floor value. Cool. So this is the second case. Now the third and the final case, when I will combine the ith flank with some flank of the different length. So this is my case 3. So here in this case, sum of v of I 0 and let's say the jth flank. So v of j 0 and plus equals to minimum of v of I 0, the frequency of the ith flank, and the frequency of the jth flank. So it must be 1, not 0. Cool. Let me give you an example for this one also. So let's say we have a 3 flank of length 2. Then let's say we have a 1 flank of length 3, and let's say we have a 2 flank of length 5. So here in this case, let's say v of I, it is simply equals to 2 comma 3, that is a frequency of flank of length 2 is 3. Then v of let's call this as a 0. So v of 0 is a 1D array, and that 1D array we have 2 elements. The first one is storing the length, and the second index we store the frequency. Then v of 1, let's say the second flank of length 3, and it has frequency 1. Now v of 2, the third flank of length 5 with the frequency 2, right? And let's call this as your ith flank. So if this is my ith flank, so how many flanks we can form? So either I combine this one with this flank of length 3, or I also have a possibility to combine this with the flank of length 5. So in that case, sum of 2 plus 3, and it will increment by minimum of frequency of flank of length 2, it is 3. Then frequency of flank of length 3, it is 1. Basically here I can form only one pair. I will take a one flank of length 2 and will take a one flank which is available of length 3 and will combine them together. So now the resulting flank would have the length 5. So increment its frequency by 1. That is, it is possible to have a flank of length 5 by the combination of these two flanks. Then sum and 2 plus 5 plus equals to minimum of 3, the frequency of length of flank 2, then the frequency of length of a flank 5. So it is a 2. So here minimum of these two values are 2. So how many flank of length 7 we can form? That is 2 plus 5. 2 flank, right? We'll take this flank and I will take this one and we'll combine them together, right? We'll take another occurrence of 2 and another occurrence of 5 and we'll combine them together. So that is it is possible to have a 2 flank of length 5 by the combination of a 2 different flank of the different length. So yes, these are the 3 possibilities we have. No other than this, nothing other than this. So this is the complete solution. The first step is to find the unique flank length and their frequency, that is create an array V. Then I'm using another map. I'm using a map. Let's name this as sum. And the sum of x will store the number of possible flank of length x after all the possible combination, after performing all the operation. So what will be my answer? Maximum value corresponding to any key x in my map sum and -1, right? And now let's just find the contribution of each and every unique ith flank, that is v of I. So we have a 3 possibility. Either we use the ith flank individually, so sum of its length, and it would increment by the frequency. Then there might be the case when we have to combine two flanks of the same length, and the length would be v of I0, the length of the ith flank. So the sum of 2 into v of I0, right? We are combining two flanks of the same length. So how many flanks we can form? The frequency and divide by 2, right? Or might be the case when we combine two flank of a different length, right? That is ith flank and the jth flank. So how many flanks we can form? Minimum of frequency of ith flank, comma, the frequency of jth flank. And make sure to iterate over all the possible values of j which are greater than I. If you start from 0, then you will end up with some overcount result. You will overcount the answer. So that's why we only consider the unique pair, because let's say you are at index 0 and then you are at index 1. So when you are considering index 1, if you again take the index 0, then you will overcount the result. That's why we'll iterate over all the j which are greater than I. So here we have fixed one thing, to iterate over only one direction. What kind of category this problem comes under? So this is basically a contribution technique, where I will find the contribution of each and every flank. So coming to the implementation. So this is my unordered map frequency, and increment the frequency of each and every element of ARR. Then here I have created a vector v, and you all know why here I have created a vector v, because it's very easy to operate over the vectors as compared to the map itself. Now this is my map sum. Then I iterate over all the unique flank. Then this is the case 1. Then case 2. And finally we have case 3. So I iterate over all the jth flank. And the value of j starts from I plus 1 and it goes till the last flank. Cool. Then initializing the answer with 1. And taking the maximum value corresponding to any key in a map sum and minus 1. So this is the complete solution. The time complexity would be n square log of n base 2, and the constraints are pretty small. So that's why it is a feasible time complexity. The value of n can be up to 500 only. So feasibly we can iterate over all the possible pairs. So the quadratic solution will pass all the test cases. So a quick +1 if it is clear to you. Okay, if you still have some doubt, then I would highly recommend everyone to just go and dry run. And everything after this, after the dry run, would be definitely clear to you. And this is a very standard technique. So make sure to recall this standard technique which I have used for all the future problems. Cool. Now coming to the third problem of the contest. So how many of you were able to solve the third problem? And I personally categorize both the problems of the same difficulty level. The last problem was a little hard, but the second and the third problem can be categorized under the same umbrella. So how many of you were able to solve the third problem? So Hemant, was you able to solve the third problem? Thought of using a KMP algorithm for every substring of in S and then check whether the substring. So yeah, maybe KMP algorithm would work, but you don't have to think in that direction, because for the third, especially for the third problem, the constraints are very small. The length of the string can be up to 1,000 only. So the quadratic solution will pass all the test cases. And the last problem, for the last problem, you can solve with the help of an KMP algorithm. And when I saw the fourth problem for the first time, I thought we have to use a KMP or Z algorithm. But later on, I realized that I can write some easier solution. Anyway, now coming to the third problem. So minimum character count. So you are given two string S and T. Your task is to find out the minimum number of character that you need to delete from S, so that S string S occurs as a substring in T. So the problem statement is very straightforward. We need to delete a minimum number of character so that S becomes a substring in string T. So for the first sample input, we don't have to delete any character. S is already there as a substring in string T. Now for the second sample input, we can delete the last occurrence, basically the last character, and now we have we have this string S as a substring in string T. So that's why the minimum number of character that we have to delete is 1. Cool. And then here we have a constraint which makes this problem super easy. The length of the string can be up to 5,000 only. So here we can write some quadratic solution, right? And the idea here is to iterate over all the substring of length t, and for every substring, not of a length t. Let me just again repeat this thing. So the idea here is to iterate over all the substring of string t, and for every substring, we check what is the minimum number of characters that I need to delete from S to make string S and that substring equal, and we'll select the best result, no doubt, right? But here I have mentioned I will iterate over all the substring, right? But we all know we don't have to iterate over all the substring of string T. We'll do some types of optimization, and but the idea is same. Now listen to my explanation. So we'll fix every index as the starting index, and we'll find how many characters do I need to delete to match the remaining string S to the substring which starts from index I in T. So I can write a logic in this way, that is for every index, let's call this as a starting index. The start is equals to 0, and this will go from 0 to the length of string T and -1, right? We'll iterate over all the possible substring. And now here I am going to find the minimum number of characters need to be deleted from string s to make it equal to the substring of string t, which starts from this index start. Now let me give you an example. So here the possible value for start. Let me write it here. The possible value for this is index start is from 0 to length of the string t and -1, right? And now let me write the example here. So let's say we have a string s and it is equals to, let's say, g, then let's say e, a, b, then let's say again we have e, then k, and let's say s and f. So this is my string s. Now let's say we have a string t, and in this string t, let's say we have some characters. Let's say we have 3 characters, and also let me write their values. So let's say this is my character a, then character b, then character c, then let's say we have character g, e, then again e, then k, s, and let's say we have 3 more characters. Let's say a, then let's say b and c again. Cool. Now let's say this is my starting index. This is my start index. So here the possible value for start is from index 0 and to the index last index, that is length of string t and -1. So now I have decided to fix this start index. So now what I will do, I will use a 2 pointer and will move this pointer one step at every point, and when the some character got matched, will also increment the pointer corresponding to this string t. So let's use a pointer variable I and initialize this I with 0. So I is equals to 0, and another pointer variable, let's say j, which is for string t, and I will initialize this pointer variable j with start. And now I'm going to check. What is the minimum number of character that I need to delete from string s to make it equal to the substring of t, which starts from index start. So the very first case, if s of I is equals to t of j. So this is an happy case. So let me write it more clearly. So the character at index I got matched with the character at index j. So I don't have to delete it. So increment I and increment j. So I plus plus and j plus plus. And what if these characters are not same. So in that case, I need to delete the ith character. Anyhow, I must have to delete the ith character. And basically, this is a greedy solution. If the ith character matches with the jth character, then it is the best time to match these two characters. It is never optimal to match the jth character with some character which is coming in future. If it got matched, then match at this moment only. This is the best solution. Otherwise, you have to delete some more characters, which is suboptimal, not optimal. So in the else part, I must have to delete. So let's declare a variable delete and increment it. Increment it by 1. So plus equals to 1. This variable delete will store the number of characters that I need to delete. So initializing the variable delete with 0. Now, and also increment the value of I. We have deleted the ith character. So take me to the next character. So let's just quickly do a dry run. So here in this case, the value of delete, which is equals to 0. Cool. Now here both the character got matched. S of I is equals to S of j. So increment the value of I and increment the value of j. Makes sense? Now again S of I and T of j both are same. So increment both the pointer variable. Now S of I not equals to T of j. Both the characters are not same. So I have to delete it. I have to delete this A. So increment the value of variable delete and increment the value of I. Take me to the next character. So again S of I not equals to T of j. So increment the value of a delete and also increment the value of I. Basically we have to delete this character B. Cool. And now both the characters are same. So in that case, increment both the pointer variables. Then again both the characters are same. So increment both the pointer variable. So this is I and J is pointing to index S. Again both the characters are same. Both the characters are same. So do not delete it. Do not delete it. Now increment the value of I and j is at here. J is at here. Cool. And then now here you can see after incrementing I have to delete it because both the characters are not same. So increment the value of j. I forgot to increment it previously. Now j is pointing to A and I is pointing to character F. So both the characters are not same. So I must have to delete it. So delete this character. So the value of delete is equals to 3. Right? So here minimum I need to delete 3 character to make S equals to the substring of T which starts from index this current index start, and this is the substring that we can match by deleting the 3 characters A, B, and F. So this is the solution. Since the constraint was very less, the value of length of the string T can be up to 5,000. So yes, we can iterate over all its substring. Cool. So yeah, this is a complete solution. Now let me show you the implementation. So here taken the length of string S, then the length of string T, then initializing answer with some bigger value, and here it is N. When I delete all the characters of S, right? And all the possible value for start, then I is equals to 0 and j is equals to start as per my explanation. Then number of characters that we delete is 0, and initially 0, then I is less than n, and j is less than m. So then in that case, first I will check if both the characters are same, then increment I and j both. So this I is outside the if else block. So because it is common in both if and else part. So increment j and increment I. In the else part, increment the variable delete and also increment I. Take me to the next index. If it is not got match, then we have to delete it. Then answer is equals to the minimum answer that we have so far, comma, delete plus n minus I. So this is an edge case which you have might miss. So for example, let me explain you with the same example. So let's say here we have another character. Let's say here we have another character S, and here also we have another character S. Let me delete this one. Then let's say we have character A and B. Cool. So here first I will check F and A do not get match. So I need to delete it. I need to delete F. So increment the value of I. Cool. And here in this case, let's call this as S instead of A. So here in this case, S of I and T of J both are same. So definitely we match it. We match it and increment the value of I and increment the value of j. So after incrementing the value of j, now you will reach out of bound, right? Now you will reach out of bound. So in that case, I must have to delete these character. This A and B, I must have to delete it. So this is an edge case. So let's call this as index as n minus 1. This is the last index, and then this is index I. So I need to delete all the character. I need to delete all the character from I to n minus 1. If the value of j reaches out of bound, that is j is greater than or equals to m, where m is the length of a string t. So in that case, I need to delete all the character. So how many characters we have? So how many character, or I can say how many length we have? Length of this substring, it is n minus 1 minus I and plus 1, right? Because I and n minus 1 both are inclusive. So then plus 1 and minus 1 will get cancelled out. So it is equals to n minus I. So yeah, then I will simply add n minus I. I need to delete these characters also. So this is the complete solution for the third problem. So write a quick plus one if it is clear to you. Okay. Arani Pawan is saying if the constraints are up to 10 power 4, then better to go for a KMP or a Z algorithm. So basically, I would recommend you to post your KMP or Z algorithm solution in the comment box. I'm really interested that how you have implemented it. So a quick plus one if the solution to this problem is clear to you. All right, so coming to the solution of the last problem, longest prefix length. So let's just first discuss what are the prerequisites for this problem. And then after I will discuss the solution. So for this problem, the prerequisite is a Robin-Karp algorithm, which is also popularly known as a rolling hash. Then binary exponentiation, and basically this is a bare minimum prerequisite. These are, and a Fermat-Little theorem. So the first one is a Robin-Karp algorithm, which is popularly known as rolling hash. And I guess this is something which is new for you. And the rest of the two prerequisites are very basic binary exponentiation, using which we can find the value of a to the power b in just log of b base 2 time. Then the third Fermat-Little theorem of a modular arithmetic section. So these are the three prerequisites for this problem, and I am assuming that you all guys know about these three things. And if you are not, then please go and learn these three techniques and then come again and listen to my explanation. All right, Hemant, have a good night. Cool. Now let me read the problem statement. So it is fairly straightforward. You are given two string s and t. You can remove at most one character from string s and find the length of the longest prefix of s, which is a substring of t, right? So here we can delete at most one character, and after deleting at most one character from string s, we need to find the length of longest prefix of s, which is a substring of t. So for the first sample input, what I can do, I do not delete any character, and because here the length of the longest prefix, it is 4, and it is a part of this substring. It is this substring. So here the length is 4. Now for the second sample input, I will delete this occurrence of s, and this will be my new resulting string s, and this prefix we have as a substring in string t, and the length of this prefix is 11. So that's why here the expected output is 11. Now listen to my explanation. So the very first thing, the problem is having a monotonic predicate nature. So the idea here is to use a binary search. So the problem is having a monotonic predicate nature. Let me give you an example. So let's say we have a string s as geeks for geeks. And let's say we have a string t, and it is geek for geek. So here in this case, what I can do, I can delete this occurrence of s. I can delete this character s, and now the resulting string s, and this prefix is a substring of length t, basically the substring, which is this entire string t. The entire string is also a substring of itself. So the problem here is having a monotonic predicate nature. If it is possible to have the answer as 11, then it is also possible to have answer as 10. It is also possible to have answer as 9. So if my check function for mid returns me true, then it will also return me true for mid minus 1, for mid minus 2, and for any value of mid less than the current mid. Any value less than current mid. So let me write the definition. So this check function will basically check if there exists a substring of length mid in string t, which is equals to the prefix of length mid in string s after deleting at most one character. So let me write this statement. Which is equals to the prefix of length mid in string s, that is s of 0, index 0 to index mid minus 1, right? Because this is the prefix of length mid, and after deleting at most one character. So it will return true if there exists a substring of length mid in string t, which is equals to the prefix of length mid after deleting at most one character from string s. So if my check function is returning true for 11, that is, if it is possible to have the length of the prefix as 11, then it is also possible to have the length of the prefix as 10. If there exists a substring of length 10 in string t, which is equals to the prefix of length 10. So basically, after deleting at most one character. So from string s, I will delete the occurrence of s, which I have mentioned, and now this is the substring of length 10, which is this is the prefix of length 10, which is a substring of length 10 in string t. So your function will return true for this 10 also. If it is returning true for 11, it will also return true for 9 also. It is also possible to have the length of the prefix as 9, which is a substring of length t after deleting one character. So my function will return true for 9. It will return true for 8 also, and up to 1. And if it is not possible to have the answer as 12, so it is also not possible to have the answer as 13, and up to minimum of n comma m, because we can extend this till infinity, but here I have the proof for all the values which are greater than minimum of n comma m. It is not possible because we are deleting the character. We are not adding the character. So that's why the maximum answer which is possible is minimum of n comma m. So the function will return false, and return false. So this is a monotonic predicate nature with one critical point, and we need to find the maximum value for which my function return true. And this is my answer. The maximum length substring in t, which is equals to the prefix of length, same length after deleting at most one character. Now, how we can solve this problem? Now we have decided, now we have fixed the value of mid. And this is the value of low, the range where we apply the binary search. From low is equals to 1 and high is equals to minimum of n comma m. Cool. Now we know, now for a particular value of mid, how we'll check? How we'll write this check function? So let me write the steps. So the first step, I will store the hash value corresponding to every substring of length mid of a string t. And basically, what is hash value? Let's say you have to compare two string s1 and s2. Let's say s1 is equals to geeks and s2 also equals to geeks. So if you have to compare these two strings, whether they are same or not, what is the possible way? One possible way that we all know is to compare character by character. I will compare the first character of S1 with the first character of S2, then second character of S1 with the second character of S2, then the third character of S1 with the third character of S2, and so on. So this is a strict checking. Will compare character by character, right? But this is not the best solution. I'm not saying like this is not the best one. This is 100% reliable. But we need to optimize this, because if we are going to implement this type of solution, then that would definitely not pass, because this time our constraints are standard. We have a standard constraint. The length of the string can be up to 10 power 5. So definitely the quadratic solution will give you a TLE. So we have to do something better. So that something better is hashing. We'll hash the string and I will generate the integer corresponding to the string. So we'll generate the integer corresponding to this string. I will generate the integer corresponding to this string. So we'll use a function, and that function is called as a hash function. So let's call this hash function as h, and I will pass s1 in this hash function, and it will generate me a key. Now we'll use the same hash function and pass s2 here. Now this hash function s2 will generate a key. Now if both the keys are same, then I can say both s1 and s2 are equal, right? And these keys are integer. And to compare the integer, we require a constant time. So this is the idea. Cool. So the first step is to generate the hash value of all the substring of length mid, and we'll store these hash value in a set, either unordered set or usual set, for a easy checking in a future. So step 1. Store the hash value of all the substring of length mid and basically will store this in a set so that in future I can easily search. Cool. Now the next thing, what will be my hash function? This h, the value of h. So here I am going to use a polynomial hash function. So writing any linear hash function is not a good idea. These are not reliable, and basically all the hash function which exist in this world are a probabilistic model. Probabilistic model, and every hash function has some cases of a collision. That is, no hash function that exists is 100% reliable. There might be the case when your hash function will give you the same key for two different strings. This is called as collision. And every hash function that exists in this entire world has some cases of collision. But the probability of a failure for the hash function is very less when you write some strong hash function. So this is a probabilistic model based on my belief that all the test cases that are generated in the backend, for every string, it will give me the unique hash value. So it is a probabilistic model, and this polynomial hash function is like very strong hash function. But no doubt it also has some point of failure. So let's say we have a string geeks, s is equals to, let's say, geeks. So in this case, now I am going to generate an integer corresponding to this string, that is a key. So here the corresponding key will be g multiplied by p to the power 0. Basically g is the first character, plus, using arithmetic addition operator, the next character e multiplied by p to the power 1, plus another next character e multiplied by p to the power 2, plus k multiplied by p to the power 3, plus s multiplied by p to the power 4. And in this way we are increasing the powers of p, and this expression, the value of this expression might exceeds the data type limit, so we'll take a mod. I will take a mod to like compress the value. Cool. And here, what is this p? This p is a prime number. You can use any prime number, but make sure it is of at least 2 digits. In my implementation, I'm using a prime number 31. You can go with some other prime number, maybe 47 or some other prime number. And the value of mod, it is a 10 power 9 and plus 7. This is the value of mod. And what is these character? These character are nothing but ordinal number. I will use the ordinal number of the character. So for example, for character A, we'll replace this thing will replace character A with 1, will replace character B with 2, and will replace character C with 3 up to character Z with 26. So I am using the ordinal number. So now we have everything as an integer. This p is integer. These characters are basically the ordinal number in English alphabet, and in this way we generate a key. We generate a hash value corresponding to every substring of length mid, and will store it in a set. Right? And this is where the rolling hash come into the picture. Every time I need to maintain a window. The window, basically the hash of a current window, hash value of a current window, and I need to shift this window, right? Basically, that's why it is called as a rolling hash. We'll remove one character, we'll add one character. So let me give you some example. But I hope now you got this polynomial hash function. Now let me explain you the rolling hash function. The rolling hash. And this rolling hash is nothing but a Robin Karp algorithm. Cool. So let's say we have a string t and it is equals to geeks for geeks. And the value of mid, let's say it is equals to 4. That is, I will store the hash value corresponding to all the substring of length 4. So this is my first substring of length 4. I can say the first window, then the second substring of length 4, then the third substring of length 4. So every time I need to shift the window. I need to shift my hash value. So for the first window, let's just find the hash value for the first window. So window 1. We all know what will be the hash value. G multiplied by p to the power 0, e multiplied by p to the power 1, plus e multiplied by p to the power 2, plus k multiplied by p to the power 3. Cool. Basically, this is the first window of length 4. Now I need to shift this window. The second window of length 4. So for that thing, I need to add the character S and delete the character G from the window. Cool. So basically, what are the steps that I need to perform? So let's say this is the ith character. So this is like a very basic syntax of a sliding window technique. So I'm expecting you all guys know about this technique, the sliding window technique. So these are the possible values of I. So I which starts from mid, because from 0 to mid minus 1, we have a first window, right? So now the value of I starts from mid and it goes till n minus 1. The last index will add the ith character, remove I minus mid character, the character at index I minus mid. So the first step, here will add t of I power p power mid, the length of the string. In my rolling hash, I will add this value, and you all know the characters which I will replace with the ordinal number starting from 1. Then I need to subtract the last character of the previous window, which is at index t and I minus mid and p to the power 0, since it was the first character of the last window. So that's why the power of p corresponding to this character is 0. Now the third thing, I need to divide it by p. Divided by p. Now let me explain you this thing. So let's call this value. As let's say lambda. Let's call this value as alpha. It's not a lambda. Now here window 2. So window 2, in the previous hash value, what I will add? So alpha, add the ith character. So plus s. This is my ith character. Ith character is s. So s multiplied by p to the power 4 and minus the character at index I minus mid. The current index s, the current index is 4 and 4 minus 4, which is equals to 0. So index 0, 1, 2, 3 and 4. I need to delete the character which is present at index 0. So which is 4 minus 4, I minus mid. So the character g and multiplied by p to the power 0. Cool. Now, and after this, the third step, divided by p. Now let me write it again. So the value of this alpha, g multiplied by p to the power 0 plus e multiplied by p to the power 1 plus e multiplied by p to the power 2 plus k multiplied by p to the power 3. This is the value of alpha and plus the new value which I have added, s multiplied by p to the power 4 and minus g multiplied by p to the power 0 and divided by p. Now this and this one will get cancelled out. Now my expression will be, after dividing it by p, it is e multiplied by p to the power 0 plus e multiplied by p to the power 1 plus k multiplied by p to the power 2 plus s multiplied by p to the power 3. So isn't it my hash function? So what I'm trying to say, now I shifted my window by one position to the right. These are the 3 steps that I need to follow, and these are the steps of a rolling hash. So again, for the window 3, let's call this value as lambda. So for the window 3, what will be the equation? Lambda plus the next character. So now this is your window. Now this is your window. This is the next character f, and this is the value of I, character f. So I need to add this character, right? And what character I need to delete? The previous character, like the last character of the previous window, character e, the character which is at index 1. So we'll add t of I, which is f to the power p power mid, p to the power 4, and minus what we need to delete, t of 1, 5 minus 4, which is equals to 1. So at 1 we have a character e. So e multiplied by p to the power 0 and divided by p. And now if you simplify the equation, then what you will get? You will get the hash value of a new window, which start from index 2 and goes till index 5. So you will get e to the power e multiplied by p to the power 0 plus k multiplied by p to the power 1 plus s multiplied by p to the power 2 and finally plus f multiplied by p to the power 3. This is the hash value of third window 3. So in this way we can shift my window in a constant time and get the hash value of a new window. So this was all about the first step. Let me just quickly summarize what I have discussed so far. So the idea here is to apply the binary search because the problem is having a monotonic predicate nature. If it is possible to have the answer as 11, then it is also possible to have the answer as 10. So we'll write a check function for a particular value of mid, and this check function will return me true if there exists a substring of length mid in a string t which is equals to the prefix of length mid, that is from index 0 to mid minus 1 in a string s after deleting at most one character from string s. Cool. So now if my check function is returning true for 11, then it will also return me true for 10, it will also return me true for 9 and all the previous values. And it will not return, it will return me false for 12, then it will also return me false for 13, 14 and so on, right? So the value of low is 1 and the value of high is minimum of n comma m, because the maximum possible answer that we can have is a minimum of m comma m, the length of any string. So you know the value of high, you know the value of low, just apply a binary search. Now I am assuming that we know the value of mid, which is equals to low plus high divided by 2, and every time we either select the left half or select the right half. Cool. So the first step is to store the hash value of all the substring of length mid in a set, and all the substring of length mid of string t in a set. And what is hash value? Here I am using some function which is so yes, that's what I have mentioned. If your answer is mid, then I know it is definitely return true for mid minus 1, for mid minus 2. And what is my basically what is the requirement here? The maximum integer for which my function is returning true, right? That will be the length of the longest prefix, which is a substring in string t after deleting one character from string s. So yes, it has a monotonic predicate nature. Then I have discussed the hash function, a polynomial hash function. And this is the polynomial hash function. Here I have selected the value of p as 31, which is a prime number, and the value of mod, which is 10 power 9 plus 7. Then you know how to find the hash value of a particular string, but I need to find the hash value for all the substring of length mid in string t. So to optimize this, I will use a sliding window technique, which is, and basically will combine the hashing and sliding window together, and this is called as rolling hash. This is just a fancy term, but it is nothing but like a combination of a sliding window plus hash function. So yeah, this is the way we shift the hash. Now we'll store the hash value of all the substring, all the window in a set, and now I need to delete the character from string s. So this is my second step. Now we are done with the first step. Now the second and the final step. I will delete the ith character of string s, and the new resulting string of s will check is the hash value of a first mid character, which is the prefix of length mid, is present in my set or not. And if it is there, then return true for this value of mid, otherwise return false. So the second step, delete ith character from string s and check if hash value of the prefix of length mid, that is index from 0 to mid minus 1, after deleting one character. Do not get confused. This statement, basically this prefix is after deleting the ith character. So 0 to mid minus 1, if the hash value corresponding to this prefix is present in a set, then I will return true, otherwise will return false. So let's say this is my the zeroth character, the character at index 0, then s of 1, s of 2, then some character s of I minus 1, then character s of I, then character s of I plus 1, and up to character s of mid minus 1, then character s of mid, s of mid. So first I will write s of mid minus 1, and then character s of mid and s of mid plus 1, which I don't need to care. So what I'm trying to say, you only need to bother about these indexes. Because if I delete the character, if I delete some character from here, then my prefix is fixed, right? So I must have to delete the character from index 0 to index mid minus 1. Let's say if I decided to delete the character which is at this index, the character at index mid. So now your prefix is same as the original string. So this prefix is same as the original prefix of string s. So I don't need to bother about these indexes. Cool. So basically the value of I is in the range from 0 to mid minus 1, or I can say this mid is exclusive, or let me write it in the more simpler way. So 0 to mid minus 1. And if I delete the character at index mid, it simply means we are not performing any operation. We are not performing any operation. We are comparing the original prefix of string s with the substring of string t. So that's why it is from 0 to mid, right? Because I also need to consider this case. And for mid plus 1, I don't need to bother about these things. I don't need to care about this mid plus 1 and all. I don't need to care about these things. Cool. So now I have decided to delete the ith character. I have decided to delete the ith character. Now this is my basically I broke this string into two half. Let's call this as left. I'm discussing everything as per my implementation, and no doubt all the names are genuine. So this is my left, and this is my right. So the current hash value will be left plus right, and we have to divide it by p. And if you find the value of left and right naively, then the time complexity would be quadratic. So that's why we have to use a prefix sum. So I will create an array prefix of length equals to the length of length mid, up to the mid only we required. So we'll create an array prefix and of length mid plus 1, right? Because from index 0 to mid I require all the indexes, and the prefix of I will store the hash value of a substring from 0 to I. So that is s0 multiplied by p to the power 0 plus s multiplied by p to the power 1, s of 1 multiplied by p to the power 1 plus s of 2 multiplied by p to the power 2 and up to s of I multiplied by p to the power I. Cool. And definitely we take the mod every time. So even if I do not mention this mod, then this is like self understood, because the values might exceed the data limit, data type limit, so we have to take the mod. Cool. Now if I decided to delete the ith character, so now what will be the value of left? So the value of left, let me just clear this thing, but you all know this would be of size mid plus 1. Now if I decided to delete the ith character, so here the value of left will be prefix of I minus 1. That is the hash value from index 0 to index I minus 1. Or I can write it this way. That is s of 0 multiplied by p to the power 0 plus s of 1 multiplied by p to the power 1 up to s of I minus 1 multiplied by p to the power I minus 1. Same as the requirement, right? But here, like the hash value which I have added, it is s multiplied by p to the power s of I multiplied by p to the power I. Cool. And what is the value at here? S of I plus 1 multiplied by p to the power I plus 1. So now you can see, when I delete the character, when I delete some character, every character will be shifted by one position, right? Every character by shifted by one position to the left. That's why here I need to divide the equation for the right half by p, so that I can manage the power. So yes, that's the complete solution. Now you know the value of current hash. So you know the value of current hash. Just simply check this current hash in a set, and if it is there, return true. For a mid, return the check function will return true if the current hash is present in a set. Otherwise, after deleting all the possible ith character, will return false. So like this session is bit long, but yeah, let it be. So where we have implementation. Cool. So this is my power function, basically the value of p here, and the value of mod, which is 10 power 9 plus 7. Then this is my power function which uses a technique of a binary exponentiation, and it will return me the value of a to the power b in just log of b base 2 time. Binary exponentiation technique. Then a polynomial hash. Okay, let me delete it because I haven't used this thing. Then this is my inverse function. Basically, I need to divide the hash value by p at some point of time, right? So this is my inverse, basically a format little theorem. That's why I mentioned it is the prerequisite. So the inverse of x is simply equals to x power mod minus 2. This is a modular division. In a modular division, the inverse of x, that is x to the power minus 1, is equals to x power mod minus 2. This is a formal little theorem. You can read about the proof. But why here I have written this thing? We'll come to this very soon. So this is my check function. But before this check function, let me show you the method that you need to complete. So this is the method that you need to complete for a string s and for a string t. So taken their length, then the value of low and the value of high, then simply applying the binary search. If the function is returning me true, so store this value, because this might be the last value for which your function is returning true. So the maximum possible length. So store it, and low is equals to mid plus 1, otherwise high is equals to mid minus 1, and finally we are returning this answer. So this is like a basic template of binary search. So now this is my check function. This is really interesting. So taken the length of a string s and m, then this is my unordered set where I will store the hash value of all the substring of length mid. Here I have used the name as len instead of mid, but you can assume that len and mid both are the same thing. So this is my rolling hash, which I initialize with 0, and power of p to the power 0. I need to start with p to the power 0. Just simply look at to this expression, window 1, g multiplied by p to the power 0 plus e multiplied by p to the power 1. So that's why p to the power 0, which is equals to 1, and I less than m, I plus plus. Cool. So here I am adding the character ordinal number multiplied by p power, and if the like value of I is less than the value of mid, then only I will increment the power of p. So what I'm trying to say, so here we have the power of p as 3, and every time I will add the power of p as 3 only. So basically as 4 only. So this is a 3, and once I incremented the power of p to 4, I do not increment it in future. So here you can see that here I have added p to the power 4, that is p to the power mid, p to the power mid, right? For the first window, I need to compute the power of p in a progressive order, p to the power 0, p to the power 1, p to the power 2, up to p to the power mid. So that's why I have written this condition. Then taking a mod, and if the value of I is greater than or equals to the mid, then I need to remove some character from the window. So the character that I need to remove is the t of I minus mid, and then this is the ordinal number and multiplied by p to the power 0, and p to the power 0, which is equals to 1. So that's why it is 1. And since we are subtracting something, so I must have to add mod. This is a basic principle of modular division, and again taking a mod and dividing this hash by p, that is inverse of p. Cool. And yeah, basically if the window is valid, that is if the value of I is greater than or equals to mid minus 1, because before the first window I do not have to insert the hash value in the set. So let me explain it to you. So for these character, for the first 3 character, I do not have to insert the value in a set. That's why I'm checking. If I was at character which is corresponding to the index greater than or equals to mid minus 1. So yes, we are done. Basically now here I have inserted all the substring of length mid in my set, their hash value. Now here I am checking one edge case. If the length is equals to n, so in that case index n does not exist, right? Index, if mid is equals to n, then index mid does not exist. So in that case, I only have one possibility. That is, compare the prefix of original string s with the substring. So if the hash, polynomial hash corresponding to the prefix of, okay, so here basically I have deleted that function, but this one, yeah, this one, this hash function, and this hash function I'm using the same idea, incrementing the power, and then in this way. Anyway, so if the polynomial hash corresponding to string s, if it is equals to the first n character of string t, then in that case, actually I need to replace this one with I need to check this in a set. So if hash value hash value hash values dot find, if this polynomial hash is present in my set, then it simply means this simply means we have a substring whose hash value is same. So in that case, I will return true. Otherwise, I do not have any possibility to delete any character. So yeah, this is the correct way. Previously, I am only checking with the prefix of t, which is wrong. And otherwise, if that is not the case, then we delete some character. So we delete some character. So here, initializing the hash value, first I am calculating the prefix. So the prefix of I is simply the hash value of a substring from 0 to I. Then I iterate over all the index from 0 to mid, and now I'm going to delete the ith character, right? So the value of left is equals to prefix of I minus 1, and the value of right, prefix of mid minus prefix of I. Let me write the value of right here. So here in this case, the value of right is equals to, just look at to this expression. The value of right is equals to prefix of mid minus prefix of I, the value of right, and we must have to divide it by p to manage the power. Cool. And if the current hash is present in a set, then I will return true. Otherwise, I will return false. So yes, this was the complete solution for the last problem. If there was something which is not clear to you, then I highly recommend everyone to like rewatch the recording of this session, and definitely pause the recording at various point, and just focus on my statement, what I have given, each and every statement. Try to draw some test cases, and everything definitely would be clear to you. So yeah, that's all from my end for the today's session. And one more thing, you can find the implementation of all the problems on my GitHub repository. So this is my GitHub repository, and this one, post contest analysis. So I will add the solution of all the 4 problem of the today's contest. So make sure to access the implementations from this repository. So I'm sharing the link in the chat box. Just go and within half an hour we'll update this repository. So yeah, that's pretty much from my end, and hope you have learned something new and enjoyed this session. So thank you so much everyone for joining it, and have a good day.
All you have to do is give us your 90 days and we'll help you in upskill and grow. So choose your favorite course, go to our website, start learning, and we are ready with your refunds. We have helped thousands of students and they have got more than 5 crore rupees of refund. So it's not only helping them in monetary terms, it's also helping them in being consistent and complete the course. So last year our completion rate was 20%, and with 390 challenge, we have seen it significantly going up. See, the idea of 390 was to make students motivated in the form of money, so that they complete the course and they get money. But our main aim was to make students consistent so that they become market ready.